we're going to now be looking at our branched alkanes. Now, in any branched situation generally, you're going to be using some groups which we're going to be calling alkyl groups. So branches in this context are generally alkyl groups. And their general formula, CnH2n plus 1. Alright? Now their suffix is "-il". And an example of an alkyl group is methyl. Now from this, the meth of course tells you the number of carbons. It's the same prefixes to show the number of carbons. So meth tells you that it is 1 carbon, and the "-il" tells you that it is an alkyl group, which means that the formula of this thing here is CH3. There you go. CH3. Alright, so you need to know this and understand this before we can really simplify and super simplify naming branched alkenes and branched alkenes too and other things for you. Alright, good so far. Alright, so on to naming these branched alkanes now. Remember, the suffix is always going to be "-ane". So don't stress yourself over that part. These are alkanes. The suffix will be "-ane" all the time. So let's look at this example. Now here, I'm going to give you 4 steps in naming these things. The first thing you need to do is you need to identify the longest carbon chain. Now remember, for you to do that, you're going to count the number of carbon atoms that are joined together in a chain in every possible direction. And let's just do that now. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So in any direction you go, you recognize that you have 4 carbon atoms. So therefore you're going to then find the prefix for 4 carbon atoms and add the suffix. So prefix for 4 is "but". Then now remember, the suffix is always "-ane". So we're just going to add "-ane". Alright, so now we're going to number our carbon chain so that the branch has the lowest possible number. Okay, and I've highlighted the branch here in purple so you can clearly see it. Okay, so we're going to number the carbon chain so that the branch has the lowest possible number. For us to do that, we're going to have to count in every possible direction. Alright, so I'm going to count from left to right, right to left, top to bottom, bottom to top, every single way. Now, when I count from left to right, 1, 2, the branch is on the second carbon, 3, 4. And when I count from right to left, let's see where the branch is. 1, 2, 3, 4. So the branch is on the third carbon, counting from right to left, and on the second carbon, counting from left to right. Now the rule says that you should use the number which is lower. The last time I checked, 2 was lower than 3. So therefore, we're going to use 2. In other words, we're going to be numbering our carbon chain from left to right. And I'm going to use my black marker here to do that. There you go. So now that we have identified the position of the branch, it's on carbon number 2, let us identify the branch. Remember, I said branches are alkyl groups. So all you're going to be doing here is just counting the number of carbons present in the branch, find the suffix for that, the prefix for that, sorry, and then add the suffix "-il". So all you're doing is really counting dots. So how many dots do you see there? 1. Very good. So you only see 1 dot. Now what is the prefix for 1 carbon? That's meth. So this must be meth. And then of course you will add the suffix "-il". So this is methyl butane. Wonderful. Good, good. Going good so far. Now we have to put the position of the branch in the name, which is what we're going to do now. So from our counting, we had that it was at position 2. So this compound is going to be called 2-methyl butane. There you have that. So that's our example right there. Okay, So in our second example, we're going to follow the same steps. 1, count the number of carbons in the longest carbon chain. So let's do that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we see that the highest number of carbons we get is 6. And the prefix for 6 is hex. You've got it. And of course, we add the suffix "in." Okay, good. Now, this structure looks a little bit complex, but let's simplify it for you, really. Okay, so our next step would be to number our carbon chains so that our branch, which I've highlighted in purple, has the lowest possible number. So let us do that now. Remember, we're counting in every possible direction. So 1, 2, 3, 4, 5, 6. Counting from top to bottom, the branch is on the third carbon. 1, 2, 3. There you have that. Now let's count from bottom to top and let's see what we get. 1, 2, 3, 4. Great. So from that we realize that the branch counting from top to bottom is on carbon number 3. Counting from bottom to top is on carbon number 4. Which means that we're going to number from top to bottom. So let's do that with my little black marker. So there you have that. Good. So position number 3. The next thing we want to do now is we want to identify the branch. Remember now, branches are alkyl groups. So all you need to do is just count the number of carbons in the branch. Remember, each dot represents a carbon atom. And as you can see, this has 2 dots. So now you need to find the prefix for 2 dots. And that's going to be our 2 carbons rather. And that's going to be F. So we end up with F. And of course you know the suffix for alkyl groups is L. So we just write ethyl. So this is ethyl hexane. But we're not done yet. So just hold it for a second. We need to identify the position of the branch. So where is this branch? We already did it. Great. It's at position number 3. So we're just going to identify that over there. And this is 3 ethyl hexane. 3 ethyl hexane. There you have it. It looked complex. It looked a little bit daunting in the beginning. But now you realize it's not so bad. Okay. So now in our third and final example, we do the same things again. Count the number of carbons to make the longest carbon chain. 1, 2, 3, 1, 2, 3, 1, 2, 3. Whichever direction you go, it's 3. So we then find the prefix for 3. Prefix for 3 is prop. And of course, we add the suffix "in." Okay. Now we need to number the carbon chain so that the branch has the lowest possible number. So let's do that. 1, 2, branches on the second, 3. Let's start from this side now. 1, 2, branches on the second, 3. 1, 2, 3. So whichever direction we go in, the branch is on carbon number 2. And that's good. So now let's identify the branch by counting the number of dots. It's 1 dot, which means that this is methyl. So methyl propane. But wait, let us put the position of the methyl group. It's actually position 2, so it's 2 methyl propane. Wonderful. This is not so bad, is it? When you really get down and dirty into what's going on. Alright, so let's move on now to our next bit of thing, which is naming substituted alkanes.